All right, let's go ahead and solve activity 231A number 9. And I kind of already started this because I started last time and accidentally closed it with my elbow on the mouse. So my bad, but reading through it, I found the force, the length, modulus of elasticity, deformation, stress. They want me to find diameter, and they want to show that the stress will be less than 30,000 psi. Listed all those knowns, the givens, unknowns, area, diameter, and we also want to kind of verify the stress. So one of the first things I'm going to do is just go ahead and verify stress, and I'm going to do that by looking at modulus of elasticity. It needs to be equal to the stress divided by the strain, and the strain is the deformation divided by the length. So strain is going to be that ½ inch divided by the 192 inches. And a ½ inch divided by 192 gives me 0.0026. Let's just stop there. And to solve for stress, stress would be then equal to the modulus of elasticity times strain. So since this is our strain, we're going to go ahead and multiply 10 million, which is our modulus of elasticity, times this, 0.0026. And we know that 26,000, give or take some change, 26,041 actually, pounds is less than 30,000. So we have verified that we are good in that regard. So now let's look at solving for the area and then the diameter. And the modulus elasticity formula is FL over A times delta. And we know force, we know length, we know elasticity, and we know the deformation. So we're going to solve for area. So I just multiplied by A and multiplied by 1 over E on both sides to get the formula looking like this. So area will be equal to the force, 9,000 pounds, times the length, 192 inches, divided by the area, which, the modulus of elasticity, 10 million, times the 1, 2, 3, 4, 5, 6, that's right, 10 million pounds psi, times the deformation, 0.5 inches. So those inches cancel, the pounds cancel, and we'll get our area in inches squared. I'm going to go ahead and do 9,000 times 192, enter, divide by, in parentheses, 10,000, 10 million. 1, 2, 3, 4, 5, 6. I got one too many. 1, 2, 3, 4, 5, 6, 2 million times 0.5. 5 million, I guess I could have just put. And I get 0.3456 inches squared. Now, our last formula that we need is area formula with diameter. So diameter squared over 4 times pi. And if we were to solve that formula for diameter, we would say that area times 4 divided by pi and the square root of that. So the diameter will be equal to the area, the square root of 0.3456 times 4 divided by pi. All right, so times 4 divide by, and I'm going to use 3.14, and then go ahead and square root it. And that gives me a diameter of 0.6635169,757 inches. It said determine the diameter and elongation limited to ½ inch, which is what we set it to. So that's the size diameter rod that we would need to have to make sure that we can have a 9,000 pound load, stress less than 30,000 psi, elongation at a maximum of ½ inch, and that would do it. So thanks for watching. If you have any questions, let me know.